Okay, this is part 2 of series circuits. I've drawn on the board here, I've drawn a 3-element series connected circuit. I've given you a source voltage of 120 volts. I've given us each of the values of resistances here. So R1 is 10 ohms, R2 is 20 ohms, R3 is another 10 ohms. And then I'm asking you in each of these areas to solve for or fill in the blanks. Now, the first step that we need to do would be to come up with an R total. Why do we need that? In order to be able to solve for the amount of current, okay? If we get a total resistance, we can divide that into our source voltage, which would then give us the current, okay? That would be I is equal to E over R. So we're going to go R1 is 10 ohms plus R2 at another 20 ohms plus R3 at another 10 ohms, giving us an R total of 40 ohms. 40 ohms divided into 120 is going to give me a new line current. So 120 divided by 40 gives us 3 amps of current. I hope I did that math correct in my head. All right? That 3 amps is flowing everywhere within this series circuit. Remember, the current stays the same throughout in the series circuit. So 3 times 10 will give me my voltage drop here of 30 volts. 3 times 20 will give me my voltage drop there of 60 volts. 3 times 10 is another 30 volts. Something you're also going to pick up on here is the fact that equal resistances will have the same voltage drops across them because they are based on the same current flowing through them. All right? So we can take this one step further and go 3 amps times our 30 volts to give us 90 watts of current, or 90 watts of power at each of these, and 3 times 60 giving us 180 watts of power there. If we did not want to use a voltage value there, we could go I squared R for each of these to come up with the same values. All right? If we wanted to get our power total, we can use our E total times our I total. So 120 times 3 to give us 360 watts. Or we could utilize this rule over here and go 90 plus 180 plus another 90 should give you 360 watts. All right? Pretty straightforward there. It gets a little bit more complex when we give you some values here and some values out here, but you're missing some. All right? Then you have to start looking at these rules and subtracting items away from it. In other words, if we didn't know what this value was here, okay, but I had given you everything else, okay, we should be able to deduce or subtract. If we've got an R total of 40 ohms, we know we've got 10 ohms there and we've got another 20 ohms there. So R total is 40, subtract 10, subtract 20 to give us a new or a missing resistance here of 10 ohms, okay? And then we can go 10 times the 3 to give us 30 volts, 30 times the 3 to give us our 90 watts again. So if those were values that were missing within there, we can pick and choose the information that they've given us, implement it in our appropriate formulas, and should be able to solve it like a little bit of a puzzle. All right? These things can be a little bit frustrating at times depending on some of the missing information, but remember, the most important thing that you can try to solve for initially will be your current. Once you have your current in a series circuit, you know it flows the same throughout. So once you have that, you should be able to start picking and choosing the information that is missing along the way and solving for that. All right? Always remember your rules in series circuits. Make sure you follow them. Make sure you double check your results to those rules from everything you've done here and your Ohm's law. And you should be okay. All right? So that ends this little 3-element series circuit.